So the guidance for the standard, okay, so the standard for timber design, we use Euro Code 5, okay, or BSEN 1995. So historically, timber is one of the earliest building material used, okay, so obviously because it's available naturally, you just have to chop down the trees and you can start building from it straight away. So no special processes required. All right. Let me see if I can zoom in a little. Okay. All right. So in engineering, timber is not the same as wood. Right. So I've mentioned that timber not the same as wood. Okay. They have slightly different meanings. So typically, the use of timber in construction, it can be used as both temporary and permanent structures. So in terms of temporary structure, you can use it for scaffolding, shuttering. So this is quite common. So if you look at formwork for casting concrete, normally they use wood or timber, all right? And shoring, okay? Now, you can also use timber for permanent structures, all right? So you can use it for beams, you can use it as a beam, you can use it as a column, you can use it as a door purlin, and you can use it even as for piles foundation. Okay. So here are some examples of temporary structures that you can use timber for. So on the very left is shoring. Okay. So basically what they're using it for is like almost like a temporary retaining wall. Okay, to show the sides of the excavation so that it doesn't collapse in. All right. In the middle, it's being used for formwork. And on the right, it's used for scaffolding. Now, for permanent structures, okay, timber quite commonly used for piling, but well, in the past, okay, not very common now. Okay, and you can use timber for the entire frame of the structure. And yeah, on left and right, okay, you see in the middle, you can see timber being used for beam and column, whereas on the right, you can see it being used as the entire frame of the building. Okay. So timber, it's a biological and naturally occurring material. So what that means is the material is highly variable as well. Okay. So different trees grows at different rates, and the soil condition, the exposure to the sun dictates how strong it gets. Okay. So even though you may get timber from the same type of trees, the strength may not be the same. All right. So physical and mechanical properties may vary according to the grain fiber direction. All right. The material is hygroscopic. What that means is the moisture content of the timber varies with relative humidity of the surrounding. Okay. So as the surrounding gets more humid, moisture content changes. Now, timber is strong in resisting both tensile and compressive stresses. Okay. It doesn't corrode, obviously, and it can last a long time if you treat it properly. So the thing with timber is you cannot use it straight away. Okay. So most of the time, when you chop down the tree, you have to cut off the sides of the tree so that you get the internal part, and then you have to treat it for fungal attack, for termite attack, all right, before you can actually use it. So timber has a high strength to weight ratio, meaning its strength is much more higher than its weight. All right. Now the thing with timber is it is susceptible to seasonal cracking and warping. Termite attacks and defects in the wood. Okay, so therefore, you need to apply factor of safety based on the exposure condition in which you use the timber. All right. So for example, if you use the timber in wet conditions, if it's an exposed timber outside of external part of a building, exposed to weathering, you need to apply a higher factor of safety. Okay, to your design. Timber has a low elastic modulus, meaning it can deform. It can undergo quite large deformation. Okay, creep. So creep is also quite common. Okay, under permanent heavy loadings. Okay, anyone knows what creep is? You know what is creep?
For me, I don't know.
Don't know. Okay, so creep. So creep is a type of deformation. Okay, creep is a type of deformation in any structure. Can be concrete, can be steel, can be timber, but it's quite common in timber. Okay, it's caused by consistently high loading. So if you apply high loading to the structure will start deforming, and this deformation is called creep. Okay, so basically what creep is, once you remove the high loading, the structure will not go back to its original shape. All right. Now, wood can also be prone to shrinking. Okay, obviously because it's biological. Okay, it has quite a lot of voids in it, so it can take in a lot of moisture and water. Okay, so therefore you should always treat the timber so it's always dry. So either you can paint it or you can treat it with a layer of you can treat it with some sort of paint to make sure moisture doesn't get into the timber. Okay, always keep the timber dry. Okay, timber is combustible. Okay, which means it can burn quite easily, and it is also susceptible to rotting or insect attack. Okay, meaning yeah, rotting. So I'm pretty sure you have your wooden door in your house. If it's a door on the external part of the house, always subjected to rain, you will notice that your door starts rotting. Okay, after some time. So therefore, again, treatment is crucial to prevent this type of damage. So timber, there are three types. Okay, there are three types of timber. You have your softwood. You have your softwood, which is what we call the C series. You have your hardwood, which is the D series, and also your engineered wood. Okay, so three types of timber generally: softwood, hardwood, and engineered wood. Okay, so hardwood. Okay, so hardwood comes from deciduous trees that have leaves and seeds. Okay, so examples of hardwood are wood that come from ash trees, your beech, your birch, your cherry, your oak. Very hard type of wood. Okay, hardwood grows slowly, but they are normally more dense and usually used for furniture, woodwork, and flooring. Okay, and they usually cost more. Softwood is quite common. Okay, in engineering. So softwood comes from conifer trees that have needles and cones. Okay, so for example, you have your cedar, your fir, your pine trees. They grow very fast, but they are not as dense. And they're usually used for building components, furnitures, exterior cladding. Okay, and they usually cost less. All right. Now, engineered wood, okay, can be real timber, can also be timber manufactured from waste wood. Okay, so these are your plywood, your MDF, your chipboard. So things that you see when they things that they build your cabinet from. Okay, your cabinet are typically constructed from chipboards or MDF. Okay, so basically waste material. They process it. Okay, they turn it into engineered wood. All right. So obviously these are manufactured from waste, so so they don't cost a lot. All right. Now, in terms of strength, okay, in terms of strength, these are the spectrum, okay, showing different type of trees and different types of strength and density, color and price. Okay, so you can I leave this in for your reference lah. Okay, but it's not important for our course. All right. Okay, so this is what's important for our course. All right. So these are basically the wood that we use for engineering design purposes. Your softwood, your C classes, so it goes all the way from C14 to C50 for softwood, and it goes from D30 to D70 for your hardwood. Okay, so these are what you use for engineering design. Okay, soft and hardwood. So just like concrete, you have different properties for all the different hardwood. So for example, let's focus on C14. Okay, softwood C14. So you can see 14 in the C actually refers to the bending strength, FMK. Okay, so when I ask you to design a beam or column using C14 softwood, you know straight away the bending strength is 14. Okay, that number there refers to the bending strength. All right, but you also get other properties. Okay, for example, tension, you get compression and shear as well. Just like similar to what you get with concrete. Okay, now you will see tension and compression. There are two types. All right, there are two types of tension. There are two types of compression. You have your tension parallel and your tension perpendicular. Okay, so what are these? So tension parallel means tension, the tension force applied parallel to the grain of the wood. So if you imagine, if you get a piece of wood, you cut the wood in half, you will see that inside the wood you actually have lines. Yeah, the wood normally there are lines. Those lines are called grain lines. Okay, so if you apply the loading, the tension parallel to the grain lines, you actually get a higher tensile strength compared to if you apply the tension perpendicular to the grain lines, you get much less strength. Okay, because obviously if you apply tension perpendicular to the grain lines, you are trying to rip the wood apart at the grain lines. Okay, so the strength is much less. Okay, and then you have your stiffnesses and your density. Okay, so as they get stronger, obviously the density increases as well. So structure constructed from wood, these are your basic layout. So so unlike steel, so when you do steel design, you can construct your beam and column from steel, but the slab has to be concrete. Okay. Now, with timber, it's different. With timber, you can actually construct everything from timber, from the floor to the beams to the joists to the column. Everything can be timber. So, so I've attached a diagram here. Okay, so you can see. All right. So you have your floor planks sitting on the joist. Now, what are joists? So you can think of joists as small beams. Okay, small beams, because obviously your wooden plank are quite thin. Okay, your wooden planks are quite thin. it cannot span very far. You cannot just put two beams and make your plank span between the beams. Okay, it's too far for the plank to span. Okay, so what you do then is alternatively, you put in joists at 500 or 600 mm centers, very close to each other, and then you span the planks between the joists. Okay, this forms the floor. The joist and the plank is the entire flooring system. Okay, the whole floor, the entire flooring system then sits on your beam, and then the beam is supported by the column. All right. All right. Okay. So next, you have your effective length. Okay. So now effective length, very similar to the effective length of a steel beam. So basically, when you calculate effective length of your timber beam, you measure from the center of support to center of support. Okay. Or if you're using bolts to connect the beam to the column, then you measure from the center of the connection to the center of connection on the other end. Okay. Right now, this one you should be very familiar with. So actions on beams. Okay. So actions of beam, generally you have flexure. Okay, this is quite common. Flexure and shear. These are the general actions you have on beam. So you should be quite familiar with this. Yeah, we've done this multiple times for RC design and steel beam design. Okay, so when you have a beam, simply supported, for example, I apply a vertical load, the beam goes into flexure. You then have a neutral axis roughly around the mid height of the beam where the stress is zero. And then at the bottom of the beam, it goes into tension, and the top of the beam goes into compression. All right. But that's not the only action. All right. So if you recall from RCD or steel design, you have flexure, you have shear, you have deflection. And with timber, you also have to consider bearing and stability, because quite often what happens is the timber joists or the timber beams, they sit on another beam. Okay. So bearing is important. You want to make sure there's enough bearing to support your beam so it doesn't just slide off. Okay. So partial safety factor. Okay. So steel and RCD, reinforced concrete design. Okay. The partial safety factor that we use is normally 1.35 for dead load and 1.5 for live load. Okay. But for timber, we use 1 for both. Okay. Live load 1, dead load also 1. So simple, easy to remember. Okay, so like I told you, timber design is much simpler compared to steel design or RC design. Okay. Now, however, you also need to apply partial safety factor for the material properties and the resistance. So obviously, as I mentioned earlier, timber as a material, it can vary quite a lot depending on where the tree comes from. Okay, and where the tree is growing. Okay, so the strength may not be exactly the strength that you specify. Okay, so therefore, in terms of material properties and resistance, you need to apply all these material partial safety factors. Okay. Okay. Now, in addition to the partial safety factor, you also have to apply what's called modification factors to your stresses. Okay. So for this course, we will only cover members in fracture. Okay, that's all we're going to check. Okay, so for members in fracture, you need to consider modification factors K1 to K6. Okay, so now we are going to talk about these factors. So K1. So modification factor K1 is related to the duration of loading. Okay, so for long-term loads, that plus impose means live load. Okay, basically. So for long-term loading, K1, you use 1. Okay. But for medium-term loading, you use 1.25. Short-term loading, you use 1.5. And very short-term loading, you use 1.75. So the shorter the duration of the loading, the higher the K1 you use, basically. Okay. So that's K1, simple. All right. Now, modification factor K2. Okay. So all these clauses are from the code. Okay. Euro code 5. So modification factor K2 is to do with load sharing system. So what that means is, for example, you have joists which are very close to each other. You have elements that are close to each other. Okay. So anything less than 610 millimeter spacing, you can actually apply a modification factor K2 because they are so close to each other, the joists, they are so close to each other that they effectively share the loading. So you can apply the load sharing modification factor K2, which is 1.1. So you increase the capacity by 10%, basically. Okay. Okay. Next is modification factor K3. Okay, so K3 is to do with bearing length. Okay, so you can see if your bearing, so bearing is basically the width of the support. Okay, the width of the support that your beam is sitting on. If your beam is sitting on a support which is only 10 millimeter wide, then there's a very high chance that your beam can slide off the support. Okay, so you go for a K3 higher. If the bearing length is only 10, then K3 is 1.74. Okay, so as the bearing length increases, the value of K3 decreases as well. Okay, based on this table. All right, basically during test and exam, I'm going to tell you what is the length of bearing. Then you just have to choose the appropriate K3 to use. Very simple, you just follow the table. All right. Okay, next. Next is K4. Okay, K4 slightly more complicated. Okay, so K4 is basically, so when you support your beams, sometimes what you will do is you will cut a notch in the ends of the beam. Okay, to rest it on the support. Now, this notch can be cut at the top and it can be cut at the bottom. Okay, so if you cut the notch at the top, your K4, you use the first formula there, A. Okay, notch at the top. If you cut the notch at the bottom, then you use the second formula B. Okay, now if you obviously if you don't have any notches in your beams, then you just ignore K4. Okay, so if no notches, you just ignore K4. If you have notches at the ends of your beam, then you have to apply K4. Okay, so you can see what notches are. So here's a diagram illustrating what the notches mean. Okay, so the diagram at the top is notch at the top. The diagram at the bottom shows a notch at the bottom of the beam. All right. Next, K5. Okay, K5 is form factor. It means the shape of the beam. So sometimes when you use beam, you may use circular section, or sometimes you may use a square section. Okay, so if your beam is circular section, you use a K5 of 1.18, or if the beam is solid square, you use 1.41. Okay, simple. All right. And finally, we get to modification factor K6. Okay, so K6 is to do with the depth. Okay, the height of the beam. Okay, the depth of the beam or the height of the beam. All right, so if your beam is 300 millimeter or less, you basically use 1. Okay, you basically use 1. If your beam is greater than 300, then your K6, you have to calculate based on that formula there. Okay, 0.81 times h. The h is the height of your beam. Okay, h squared plus 92,300 divided by h squared plus 56,800. Okay, for your solid beams. Okay, and that's K6. So that's basically nice and simple today. Okay, tomorrow we will probably go through one or two examples, and then that's it for timber design. Okay, nice and simple. Okay, any questions today?
No,
Or
for that way.
okay, so it's quite straightforward. I will share the slides with you now. Yeah, okay, so I've shared the slides with you. Okay, so tomorrow we will have a physical class, all right, where we will go through an example or two, okay, for timber design. All right, so before you leave, let's do the usual attendance. All right, stop sharing. Show QR code. Okay. All right. Can you see the attendance? Okay. Yeah, you can. Not once you've done the attendance, you can leave. I will see you tomorrow.
Thank you, Doctor.